The birth of chemicals, from the dawn of the universe to modern complexity. Chapter 1, The Big Bang and the First Elements, 13.8 billion years ago. The beginning, 13.8 billion years ago, the universe began with the Big Bang, an unimaginably hot and dense singularity that rapidly expanded. In the first fraction of a second, temperatures were so extreme that matter as we know it didn't even exist. Only fundamental particles like quarks and electrons swirled around in a chaotic, high-energy plasma. Nucleosynthesis, first 3 minutes as the universe expanded, it began to cool. At around 1 second after the Big Bang, the temperature dropped enough for the formation of protons and neutrons, the building blocks of atomic nuclei. These particles combined during a process called Big Bang nucleosynthesis, which lasted for about 3 minutes, forming the simplest atomic nuclei. Hydrogen, 75% the most abundant element in the universe, formed from single protons. Helium, 24%, 2 protons and 2 neutrons came together to form helium nuclei. Lithium, in very small amounts, lithium nuclei also began to form. No complex chemicals yet. At this stage, the universe was a vast, hot soup of particles, mostly hydrogen and helium nuclei, with free-floating electrons. These first elements were just atomic nuclei, they had not yet formed into full atoms or molecules. Chapter 2, The Formation of Atoms and the Dark Ages. Cooling and atom formation, 380,000 years later. As the universe continued to cool over the next few 100,000 years, it reached a point where the atomic nuclei could finally capture free electrons, forming the first neutral atoms in a process called recombination. This is when the first real chemicals, hydrogen and helium atoms, came into being. The Cosmic Dark Ages. Once atoms formed, the universe became transparent to light, but there were no stars or galaxies yet. This era is known as the Cosmic Dark Ages because there were no significant sources of light, only clouds of hydrogen and helium drifting through space. Chapter 3, The First Stars and Stellar Alchemy, 100 to 200 million years later. The birth of stars. Over time, gravity caused the hydrogen and helium to clump together into denser regions. These clumps grew larger and hotter, eventually igniting nuclear fusion at their cores. This was the birth of the first stars, about 100 to 200 million years after the Big Bang. Stellar nucleosynthesis, the forge of elements. Inside these stars, extreme temperatures and pressures caused hydrogen nuclei to fuse into helium in a process known as stellar nucleosynthesis. This was just the beginning. As stars evolved and aged, they began to fuse helium into heavier elements like carbon, oxygen, neon, silicon. In the cores of massive stars, elements up to iron were produced. But here's the catch: iron fusion doesn't produce energy, it consumes it, so when a massive star starts creating iron, it's on the brink of collapse. Chapter 4, The Cataclysmic Death of Stars, Supernovae and Heavy Elements, 1 billion years after Big Bang. Supernova explosions. When a massive star exhausts its nuclear fuel, its core collapses under its own gravity, and it explodes in a brilliant event called a supernova. This explosion is not just a spectacular light show, it's also a cosmic forge for creating even heavier elements like gold, silver, uranium. In these brief, violent moments, supernovae scatter heavy elements into the universe, enriching interstellar space with the building blocks needed for planets, life, and everything we know. Chapter 5, Formation of Molecules and Galaxies. Molecules in space. As the universe continued to evolve, clouds of gas enriched with heavier elements began to cool. The atoms in these clouds collided and combined to form the first molecules. Simple molecules like hydrogen gas, H2, and water, H2O, started to appear in space. Galaxies and star systems. Over hundreds of millions of years, these clouds coalesced under gravity to form galaxies. Within galaxies, stars and planets began to form from these chemically enriched clouds. Our own Milky Way galaxy and solar system formed about 4.6 billion years ago from one such cloud of gas and dust. Chapter 6, Chemical Evolution on Earth, 4.5 billion years ago. The Earth forms. As the early Earth coalesced from the solar nebula, it was bombarded by asteroids and comets rich in various elements and compounds. These impacts delivered essential elements and water, crucial for the later development of life. The primordial soup. On early Earth, the atmosphere and oceans were rich in simple molecules like methane, CH4, ammonia, NH3, water, H2O, and hydrogen, H2. Lightning, volcanic activity, and UV radiation helped trigger chemical reactions that produced more complex organic molecules, such as amino acids, the building blocks of life. The first life forms, 3.8 billion years ago. Around 3.8 billion years ago, these organic molecules combined into self-replicating molecules, leading to the formation of the first simple life forms. Over millions of years, these simple organisms evolved, and with them, the complexity of chemicals on Earth. Chapter 7, Modern Chemistry, the Age of Discovery, 1600s, Present. Alchemy to chemistry. For centuries, humans sought to understand the nature of matter through alchemy, a blend of science, mysticism, and philosophy. However, in the 17th century, the foundations of modern chemistry were laid by scientists like Robert Boyle, who emphasized experimentation and the scientific method. Periodic table. In the 19th century, Dmitri Mendeleev revolutionized chemistry by organizing the known elements into the periodic table, based on their atomic structure and properties. This chart became a roadmap for discovering new elements and understanding chemical reactions. Chemical industry and modern synthesis. In the 20th and 21st centuries, chemistry progressed rapidly. Scientists learned how to synthesize complex chemicals, leading to breakthroughs in materials science, medicine, and technology. Today, chemistry allows us to create everything from life-saving drugs to the materials that form our smartphones. Conclusion. From the Big Bang to today. The formation of chemicals is a story of cosmic evolution. From the birth of simple elements like hydrogen and helium in the Big Bang to the formation of complex molecules on Earth, chemicals have shaped the universe. Today, the diversity of chemicals underpins all of modern science, technology, and life itself. This epic journey shows how, from the simplest of beginnings, the universe has evolved into a place filled with extraordinary complexity.